friends, this is Grishma from CSC A section second year BTech from Madhushankara Institute of Technology. Today I am going to discuss about OS desktop topic kernel IO subsystem in operating system. First of all, we are discussing about the protection and security. So in kernel IO subsystem in operating system, so the kernel provides many services related to IO. Several services such as scheduling, caching, spooling, device reservation and error handling are provided by the kernel. IO subsystem built on the hardware and device driver infrastructure. The IO subsystem is also responsible for protecting itself from errant processes and malicious users. There are some types of present in operating system. These are scheduling, caching, spooling, device reservation and error handling. Now we can discuss about the types in operating system. First of all, IO scheduling. To schedule a set of IO, the request is to determine a good order in which to execute them. The order in which the application issues the system call is the best choice. Scheduling can improve the overall performance of the subsystem, can share devices access permission fairly to all the processors, reduce the average waiting time, response time, turnaround time for IO system to complete. OS developers implement the schedules by maintaining a wait queue of the request for each device. When an application issues a blocking IO system call, the request is placed in the queue for that device. The IO scheduler rearranges the order to improve the efficiency of the system. Next one is buffering. A buffer is a memory area that the data is being transferred between the device or between a device and the application. Buffering is done for these reasons. The first is to cope with a speed mismatch between the producer and consumer of a data stream. The second use of buffering is to provide the adaptation for data that have different data transfer sizes. The third use of buffering is to support copy semantics for the application IO. Copy semantic means suppose that an application wants to write data on a disk that is stored in its buffer. It calls the write systems call, providing a pointer to the buffer and the integer specifying the number of bytes to write. And third one is caching. A cache is a region of fast memory that holds a copy of the data. Access to the cached copy is much easier than the original file. For instance, the instruction of the currently running process is stored on the disk, cached in physical memory and copied again in the CPU's secondary and the primary cache. The main difference between the buffer and the cache is that a buffer may hold only one existing copy of the data item, while a cache by definition holds a copy and faster storage of an item that resides elsewhere. Fourth one is spooling and device reservation. A spool is a buffer that holds the output of a device such as a printer that cannot accept interleaved data streams. Although a printer can serve only one job at a time, several applications may wish to print their output concurrently without having their output mixes together. The OS solves this problem by preventing all output from continuing to the printer. The output of all applications is spooled in a separate disk file. When an application finishes printing, then the spooling system queues the corresponding spool file for output to the printer. Fifth one is error handling. An OS that uses protected maintain guard against many kinds of applications errors so that complete system failure usual result of each minor mechanical glitch devices and IO transformers can fail in many ways, either for transient reasons as when a network becomes overloaded for permanent reasons, as when a disk controller becomes defective. And sixth one is IO protection. Errors and the issue of protection are closely related. A user process may attempt to issue illegal IO instructions to disrupt the normal functions of a system. We can use the various mechanisms to ensure that such disruptions cannot take place in the system. To prevent the illegal IO access, we define all IO instructions to be privileged instruction. Next, we can discuss about the protection. In protection, we have different types of methods are there. First one is goals of protection. Protection can improve the reliability and the errors at the interface between the systems. And principles of the protection. It indicates the program users and even system can be gives just enough privileges to perform their task. Then the domain of the project. A computer system is a collection of processes and objects. Objects means both the hardware and objects and software objects. The operations that are possible may depend on the object only. And then the domain structure. The ability to execute an operation and an object is called the access right. A domain is a collection of access rights that is an ordered pair. So for example, less than object dot name comma right dot set greater than. Domain do not need to be disjoint. They may share the access right. And next of all, we can discuss about the security. Security is one of the main topic in kernel IO subsystem. There are some program threats are useful in security. Processors along with the kernel are the only means of accomplishing work on a computer. These are Trojan horse, trapdoor, logical bomb and viruses. First of all, Trojan horse. A core segment that misuses its environment is called a Trojan horse. Trapdoor. The designers of the programmers or systems might leave a hole in the software that only the designer is capable of using it. And then third one is logical bump. When a predefined set of parameters permits on the security hole would be created. This scenario is known as also a logical form. And fourth one is viruses. Viruses are the self-replicating and these are designed to impact other programs. A virus is a fragment of code embedded in a program. These are some of the protection and security methods in IO kernel subsystem. Thank you.